Something extraordinary has just happened. For the first time in modern astronomy, the James Webb Space Telescope has observed a collection of cosmic events so bizarre, so interconnected, that scientists across the world are rethinking everything we thought we knew about the origins of life and the nature of the universe itself. In a single month, the telescope captured crystalline water ice forming around a young star, carbon-rich disks swirling around newborn planets, and even chemical signatures that seemed to defy the laws of physics. But that wasn't what stopped the world. It was what Webb found next. Inside the darkness between stars, in the atmospheres of alien worlds, and in the very building blocks of what we call existence. From frozen oceans on distant planets to chemical trails that mirror life itself, the universe just sent us a message. And this time we finally understood it. It all began with a young sun-like star, HD Waitit 1327, just 155 light-years away. Using its near-infrared camera, Webb peered into a dusty ring of debris swirling around this infant star, the kind of place where planets are born. What it found was stunning. More than 20% of the disk's mass is made of crystalline water ice bound together with dust grains, forming what scientists now call dirty snowballs. These are the seeds of oceans, the very material that once bombarded early Earth and gave rise to life. But here's the catch. This system is only 23 million years old, still in cosmic infancy. The water is already there, waiting before planets even form. For decades, astronomers believed water arrived late in a planet's history. Webb just proved the opposite, that water exists from the beginning, shaping the birth of worlds long before they can ever host life. In that frozen halo of light, the telescope may have witnessed the first chapter of creation itself. While the star HD Waitit 1327 unveiled the birth of water, another discovery came from a world far stranger, a young gas giant named CT-CHA-b, orbiting a dim sun 620 light-years away. Webb's mid-infrared instruments detected something never seen before, a planet with its own debris disk, a swirling ring of carbon-rich dust encircling the planet itself. This wasn't a ring system like Saturn's, but an entire miniature version of a solar system forming around a planet, not a star. The chemistry inside was completely alien. Unlike the icy composition seen in stellar disks, CT-CHA-b's environment was dominated by carbon compounds, complex reactive molecules that form the backbone of life. It suggested that carbon-based chemistry might begin in places scientists never imagined possible. The discovery shattered old models of planetary formation, forcing researchers to accept a stunning idea, that planets may not only form from starlight, but from darkness. But Webb wasn't done. Pointing its golden mirrors toward a dim brown dwarf named Wolf 1130c, the telescope detected something that left scientists speechless: vast amounts of phosphine gas. On Earth, phosphine is produced almost exclusively by microbial life or human industry. Its presence near a failed star, a body too small to ignite nuclear fusion, defied every natural explanation. How could a world without energy or sunlight generate a gas so intimately tied to biology? Some suggested chemical reactions deep inside metallic clouds. Others whispered about something stranger, that phosphine could be the chemical footprint of processes we don't yet understand. To the scientific community, it was déjà vu. They had seen this before years earlier on Venus, another phosphine signal that was dismissed as a glitch. But this time the evidence was undeniable. Somewhere between a planet and a star, in the cold twilight of Wolf 1130c, the signature of life, or something very much like it, was burning. Then Webb turned its gaze deeper, not toward nearby stars, but to the dawn of time itself. There, in the faintest corners of the early universe, it found something no one expected. Dozens of red points of light scattered among primordial galaxies. At first, they were thought to be distant stars. Then came the shock. Their luminosity was too intense, their energy too concentrated. They weren't stars and they weren't galaxies. Webb's spectrometers revealed what no telescope had ever seen before: objects that are both stars and black holes at the same time. Scientists call them black hole stars, hybrids formed in the chaos of the universe's birth. Small black holes consuming matter so fast that they glow brighter than entire galaxies, cloaked in a luminous shell of energy that mimics a star's surface. For the first time, humanity was witnessing the monsters that built the cosmos, the ancestors of every galaxy we see today. The finding wasn't just historic, it was existential. If these hybrids truly existed, then the universe began not with order, but with hunger. While the James Webb Telescope was busy capturing the birth of galaxies, it also turned its golden eyes toward something much closer: Saturn and Uranus, the sleeping giants of our own solar system. For decades, we believed we understood them. Frozen worlds wrapped in storms, predictable, unchanging. But Webb's infrared vision revealed that their atmospheres are alive, breathing, shifting, pulsing with energy. On Saturn, Webb detected enormous plumes of methane rising and falling in rhythmic waves, as if the planet itself were inhaling. The shock came when scientists compared these fluctuations to solar data. The pattern matched perfectly with the sun's rotational pulse, as though Saturn was somehow synchronized with the heartbeat of our star. On Uranus, things were even stranger. Webb captured a massive vortex near the North Pole, so vast it could swallow Earth whole. Yet inside it, temperatures spiked to levels no model could explain. The gases within seemed to generate heat spontaneously, hinting at unknown chemical reactions, or perhaps even electrical feedback within the planet's magnetic field. For the first time, astronomers began to suspect that gas giants might not just be planets. They could be natural reactors, driven by forces that connect them directly to the sun itself. Then came Pluto and Makemake, two frozen relics orbiting the edge of our solar system. To most, they were dead worlds, icy, distant, insignificant. But when Webb turned its instruments toward them, both glowed faintly in infrared light. That glow wasn't from sunlight, it came from within. Deep under layers of nitrogen ice, Webb detected unexpected thermal emissions, signatures of subsurface heat. On Pluto, that heat pulsed rhythmically, radiating in waves every few hours, while Makemake's signal was stronger, steady, and constant, as if something beneath its crust was alive with motion. Chemical scans revealed traces of methane clathrates, crystalline structures that trap gases under pressure, often associated with geothermal activity. But the real mystery lay in the spectral fingerprint: complex hydrocarbons, the kind that form from organic chemistry. In one sweep, Webb had turned two frozen rocks into candidates for habitability. Beneath their lifeless surfaces, there might be hidden oceans heated from below, carrying the same elements that once sparked life on Earth. The discovery was nothing short of revolutionary. Life in the solar system might not orbit the sun, it might hide in the dark. Beyond our solar system, Webb continued its search for reflection, worlds that could mirror our own. It focused on K2-18b, an exoplanet 120 light-years away, orbiting a cool red dwarf. Earlier telescopes had hinted at water vapor in its atmosphere, but Webb went deeper, decoding every layer with unmatched precision. What it found left scientists stunned: methyl cyanide, dimethyl sulfide, and carbon dioxide, chemicals that on Earth are only produced by living organisms. The data was clear. This was no sterile atmosphere. It was active, dynamic, potentially biological. K2-18b, once thought to be a mini Neptune, might instead be a Hycean world, a planet covered in a global ocean beneath a thick hydrogen sky. Even more astonishing, the telescope detected subtle fluctuations in light absorption consistent with cloud formation, clouds that seem to gather, dissipate, and return in rhythmic cycles. If confirmed, it would mean this alien world experiences something very much like weather. Not storms of dust or fire, but water just like Earth. For the first time, we could be looking at a planet that breathes, reigns, and evolves under the same cosmic chemistry that gave us life. And then came the discovery that stopped even the most skeptical minds. Webb turned its gaze toward the TRAPPIST-1 system, that tiny cluster of 7 rocky worlds orbiting a dim red sun just 40 light-years away. For years, scientists had dreamed of it as a miniature version of our own solar system. But what Webb found was far more complex. The telescope detected massive flares erupting from the parent star, waves of radiation powerful enough to strip atmospheres away. Yet 3 of the planets still showed spectral fingerprints of carbon dioxide, ozone, and water vapor. That should have been impossible. To survive such radiation, their atmospheres must have been regenerating, replenished from within like the Earth's magnetic field shields us from the solar wind. In other words, these planets weren't dying, they were fighting back. Even more shocking, Webb found traces of nitrous oxide, a gas often linked to biological activity, swirling above one of the worlds, TRAPPIST-1e. It was faint, almost lost in noise. But there, for the first time, a telescope had glimpsed a chemical breath that might not be geological, but biological. A world orbiting a star we once dismissed as too dim to sustain life could be alive. And if it is, it means we are not the exception. We are the pattern,